So this is where we stopped last lecture. We finished our discussion on the body composition, and we started talking about the classification of nutrients and the recommended amount of nutrients, which is food, that an athlete should be taking in. And the recommended amount of carbohydrate, fat, and protein for your intents and purposes is 50, 30, 20. So if I was going to open up a company and try to manage people's habits, I would work on this basis here. Your brain needs carbohydrate to function. Muscle glucose is what makes your muscles contract to do anything. Like, why would you have no carbohydrate? Now, if you have all of the carbohydrate all right now, and all you do is drink straight glucose water, then you're going to get obese because you cannot possibly use all of the sugar right now. So if you have carbohydrates that are more complex, that break down over a longer period of time, then those carbohydrates are actually less destructive to the pancreas and less likely to get stored, especially if you're exercising. So in regards to fats, fats are the backbone of all of your cellular walls. So you don't want to get rid of that, because then your cellular structures lose their integrity. Also, there's vitamins and that need fats to be absorbed. There's thermoregulation reasons why you want fat. My athletes also, they're like pounding on their bodies. To have a little bit of fat provides a little bit of like padding, protection. So fat isn't a bad thing. You could also consider a down lineman in football needs to have a little bit of fat, because momentum is mass times velocity. So increased mass for a sumo wrestler, it's not a bad thing. Increased fat for a swimmer is not a bad thing. Fat is buoyant. Fat floats on water. So if I was a swim coach, I don't know if it would be my goal to eliminate fat. If you think about like what Tom Brady talks about, he's not trying to gain a huge amount of muscle mass. He's trying to make sure that his muscles are very like limber, or that are stretchy, that have an elastic region to them, so that if he gets like sacked, he doesn't tear his bicep or tear his pec or whatever. So it's not always the case that we want to, eliminate carbohydrate or eliminate fat or eat like 10,000, egg whites a day. You want to have enough fuel to carry out your activities of daily living, your digestion, and any exercise that you're doing above and beyond your activities of daily living in your basal metabolic rate. You want to have enough fats to maintain, cellular structure and make it so that your body has fuel for low intensity exercises, so you can save the good fuel for later, or the high potency airplane fuel for later. And you need to have some protein so that you can synthesize tissue. Now, if you take a look at these values here, we looked at them last week a little bit. The amount of protein, now this says carbohydrate and protein recommendations should be based adequate intake for training and goals. But it says this is like your range. The range is 1.2 to 1.7 grams of protein per kilogram. I'm 65 kilograms. DJ, let's go with DJ. DJ's got to get to 5,000 calories. That's his goal. So DJ, how many pounds, like what do you weigh?
200.
200 200 divided by 2.2. 200 divided by 2.2 is how many kilograms? So let's go 200 divided by 2.2. And so DJ is 90.1 kilograms. 90.9, no, it's 91, but whatever, 90 kilograms, it's good enough. So that means 1.2 grams of protein per kilogram. So 1.2, 90 times 1.2 is equal to 108. So that's anywhere from 108 grams of protein to 1.7 times 90 equals 153. So this is the amount of protein in grams that he should have. Well, what does that mean? Typically, the diet in the United States has so much protein in it that we far exceed this value. So I'm also going to just do this calculation here. You should have 3 to 12 grams of carbohydrate per kilogram. So kilograms is, again, he's 90 times 3 equals 270. 270 to, this is 90 times 12 equals 1080. Now, remember, this is in grams. Grams of protein, grams. And for every gram of protein and every gram of carbohydrate, it's different than fat. All right. For every gram of protein, it's 4 calories. And there's 4 calories in every gram of carbohydrate. And can anybody tell me how many grams of calories or how many calories are in 1 gram of fat? It's a good number.
9.
Right. Righto. All right, so we have to multiply this number here because this represents our protein. And this one here represents our carbohydrate. So if we want to know how many calories we have to ingest, we'd have to multiply this number of grams by 4. So 108 multiplied 108, clear, 108 multiplied by 4 equals 432 calories of your 5,000 calories. 432 to 153 times 153 times 4 equals, holy smokes, 153 times 4 equals 612. So of your 5,000 calories, 432 to 612 should be protein. Now, 612, if you're trying to get swole, bro, and it's like off season and you're trying to do hypertrophy training for sure. And then here's 270 grams, but we got to multiply that by 4. 270 by 4 equals 1,080 calories of the 5,000 should be carbohydrate, but that's not you because you're exercising. So 12 times 3 times 90, yep, 12 times 90 equals, 1 second, 12 times 90 equals, what? Oh, no, sorry. times 4 equals 4,320 calories, right? Now this is protein. This is total. That's total. This is protein. This is carbs. All right, DJ, this is carbs. And the rest is fat. So like somewhere between here, if you're trying to put on muscle mass and you're going to the gym and it is hypertrophy training, right? You're housing carbs. And then I got to get you to understand what 432 calories of protein is and what this means. It's easier for me to explain to you things in grams because all of the labels on the foods are all in grams of carbohydrates. So it's easier for me to explain it to you there. Well, let's get into the lecture a little bit more and see where we go. DJ, maybe I can keep working with you because we have so much information already on you, if that's okay.
Yeah, works for me.
All right, sweet. All right, so I'm going to clear this and let's move on. So now that we know what percentage of carbohydrate, protein, and fat we should be at, let's go take a look at how to get there. Now, in regards to carbohydrate, because that's the most important thing, this is our fuel, this is gasoline. There are some mono is 1 and saccharide is sugar. There are some sugars that are like simple molecules, boom, 1 molecule of sugar. Now, the simplest molecule of sugar is glucose. And this is what your brain and your muscles specifically use for energy. And the chemical structure of glucose is C6H12O6. So it's made of carbons, hydrogens, and oxygens. It's made of 6 carbons, 12 hydrogens, and 6 oxygens. And when your body uses it for fuel, it breaks this in half. Boom, splits it in half into 2 6-carbon molecules called pyruvate. And then that pyruvate either is combined, pyruvate is combined with oxygen or is not combined with oxygen. And if it's not combined with oxygen, it becomes lactic acid and makes your muscles acidic. So that's if you don't have oxygen. And if you do have oxygen, then it goes into the mitochondria if there's oxygen and into the Krebs cycle. So we talked about that a lot. I don't want to get into it anymore, but so monosaccharides, simple sugars go through this process almost immediately. So if I take, for instance, glucose and mix it in water, it's such a simple form of sugar that there's nothing really that needs to break down. So that sugar is absorbed into the bloodstream immediately. So if I had 1,000 calories and I'm trying to eat 1,000 calories of carbohydrate and Skilo needed to get to 4,000, and he took 1,000 calories of sugar, table sugar, mixed it in water, and he drank it, which is what you're doing when you make lemonade, you know, that lemonade powder and Coca-Cola and all that stuff. He takes 1,000 calories and drinks it. There's nothing stopping that sugar from being absorbed into the bloodstream immediately because most of it is just a monosaccharide or a very, very simple sugar. So what happens is the 1,000 calories is absorbed into the bloodstream, whoop, immediately. And whoa, your body's like, oh my God, what is this 1,000 calories? So your pancreas has to send out a huge amount of insulin to deal with this influx of energy, this influx of sugar. And the insulin is going to try to attach to the sugar molecules. And what insulin does is it transports and deals with sugar. So the insulin is going to attach the sugar, try to bring it to the muscles for fuel. Whoa, the muscles aren't exercising. Okay, what are we going to do now? Well, we don't want to get rid of the insulin. The sugar, because sugar is valuable cash. We're going to bring it to the liver, and the liver is going to decide what to do with it. The liver is going to make it either into glycogen, which is going to get stored in the muscle or the liver, or if there's too much glycogen, the liver's still not going to want to get rid of it, so it changes it to adipose fat. So if I drink like a glass of apple juice, orange juice, Coca-Cola, anything that breaks down very quickly, and I'm not exercising, there's only one spot for that sugar to go. That's just adipose fat. Now, if I am exercising, though, then that sugar is going to get broken down differently. My guys are spending, just like Alice is spending 4,000 calories, my athletes are spending the similar. So for them, I don't mind Gatorade. I don't mind apple juice, orange juice. My guys have, Starbursts. During practice, it helps maintain their energy levels. But for the regular population, I wouldn't. But we got to just keep talking about exercisers, exercise physiology. Very simple sugars: glucose, fructose, galactose. More complicated sugars: polysaccharides, like fiber. Fiber is sugar. Here's a bunch of other sugars that are more complicated than the monosaccharides, and maybe not as complicated as fiber, but sugars nonetheless. Potato, corn, French fries, pasta, bread, all of this, all of the Halloween candy, all of it, milk, all of it, lactose, maltose, fructose, high fructose corn syrup, all of that. It's just sugar. Same thing: sugar, 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 sugar. Wheat, bran, everything from Dunkin' Donuts. Every single thing is just carbohydrate. It's fuel, but the problem is with these monosaccharides, and it's not the problem, but if sugars are easily broken down and all of this 1,000 calories of sugar gets into your bloodstream, it's going to make your pancreas have to fire so hard to get so much insulin that eventually the pancreas breaks, and that's diabetes. So you want to chill on these monosaccharides. But sugar is fuel, gasoline, and it's the only thing that your brain uses for fuel. So when people say that they're going to have a no carb diet, I don't think that makes any sense to me. And when you're tired and laying down in class or falling asleep at 11:22 in the afternoon, I don't think anybody's tired at 11:22. I think that maybe your brain might not have enough glucose, so have yourself an orange juice. And rather than that, have yourself an orange that is less broken down already, and a glass of water. Then the orange will get into your body, but it'll take time to break down because the orange has cellulose and like the actual like structure of the orange itself. So it gets into your stomach. You're still going to have the same amount of energy that you would if you squoze the orange, but you would have the energy over a longer period of time. And if you had the glass of water, you would have the hydration from it. So you wouldn't get the insulin spike. You wouldn't get the crash from the orange juice. And like sometimes when I'm like, wake up I drink orange juice and I can feel it in my blood instantaneously as soon as it gets into my throat. Right? So what you would want to do though is have the orange itself and a glass of water, and that's a better way to distribute the calories more effectively.
I have a question.
Indeed, go for it.
It's kind of different, but I was thinking about maple syrup, and I wanted to know if it would be better for you to have like a normal pure maple syrup rather than a fake one that's less calories.
I mean, I can't really speak on the chemistry of maple syrup, but I could say this is the two ways that I would answer it. If you're gonna eat crap, you may as well go for the best crap. You know what I mean? And like, there's nothing that can replace pure maple syrup. And if I was a bear, I would eat it and drink it. Like, that's it. That's all I would eat. So like you may as well go with the good maple syrup at that stage of the game. But there is a product called corn syrup, and there is another product called high fructose corn syrup. I'm sure you've heard of high fructose corn syrup. Now, when glucose gets into your bloodstream and it attaches to insulin, that combination is in your bloodstream. Eventually, it's going to get to your brain. And when it gets to your brain, it tells your brain at some point, I've had enough food, I've had enough calories. Maybe I should stop eating. What high fructose corn syrup does is it shuts down that response. That's why it's used. So you could go and have 500 calories of Coca-Cola. And if it has high fructose corn syrup in it, it won't make you full. So you can continue to eat the rest of the meal that you got at the fast food restaurant that you're at. So the high fructose corn syrup thing is like almost like a marketing scheme that's, I think, taking advantage of biochemistry to make it so that you buy more product. So because of that, what I would do is probably lean towards the regular maple syrup because it's just healthier for you, I would think, and it tastes better. But I like
Okay,
where you're
thank
going.
you.
I do love myself some maple syrup. So what we want to use is carbohydrate as our energy source. And then what we want to do is regulate fat and regulate protein. Now, by regulate fat, I think that what you want to do is, you know, we already talked about the 50-30-20 split between carbohydrate, fat, and protein, 30 and 20. What I would showcase in terms of knowledge about this topic is number one, that the basal metabolic rate and energy expenditure calculator that I showed you, and also the exchange document. And then getting to your 50-30-20 splits, you use the exchange document and you're good. I don't know much more about it. So in regards to carbohydrates, I would say we want to make sure that you understand the difference between high, low glycemic index carbohydrates, and maybe how to manipulate that and layer that, or who would want to eat high and who would want to eat low glycemic index carbohydrates as an athlete, and when and why, and things like carb loading. So we would talk about that. In regards to fat, the number one thing that I would talk about fat is cardiovascular disease. It's not necessarily how much fat, the 30, the 25%, whatever. It's if you're just eating spoonfuls of lard, if you're eating spoonfuls of fat that has low density lipoproteins, LDL, saturated, like just fat that's terrible for your arteries, then you have a whole other problem associated with things called arteriosclerosis, plaque, and cardiovascular disease. So if you can keep these fats here regulated so that you're ingesting fats that have very little low density lipoproteins, low amounts of that, and very good amounts of high density lipoproteins, that's the number one thing that I would suggest there. And then in regards to protein metabolism, it's not the more protein you eat, the bigger muscles you get. It's the periodization chart and the reps versus the sets that you're having the guys doing and the amount of rest that they get. So it's the workout plan that you're doing, and whether or not they're at the 4,500 calories or the 4,000 calories and can actually have the resources to make more muscle mass. One of my guys in the gym put on 17 pounds since August. 17 pounds, right? He's 15, 16 years old. Boom. Any excess carbohydrate is stored as glycogen. Or if there's too much and you're not exercising, it's stored as fat. So how much carbohydrate your intake is going to have a lot to do with determining how much is stored. I want to maybe go a little bit faster so we can get through our review. We already talked, in order to just maintain the amount of glycogen that's in your muscles. Remember, glycogen is the storage form of sugar in your muscle and in your liver. We need at least 3 to 12 grams of carbohydrate per kilogram body weight. So skilo is 90 kilograms times 12 equals 1,080 grams multiplied by 4 equals 4,320 calories. 4,320 calories. Man, why does it do that? Let's go with this. So DJ needs about 4,300. Let's go, may as well do the bottom one. 90 times 3 equals 270 times 4 equals 1,000. That's 1,080. 1,080. 1,080 to 4,320 calories. Now, that's per day just to make sure that he can maintain muscle glycogen stores. Yeah, I would bet he probably needs close to like 3,500 calories per day at least, DJ, right? If you're doing what you're doing. The 4,320 is probably like for somebody who's pumping out 6,000, 6,500 calories a day. But for you, I would bet you want to be at 3,500 calories per day. Now, like Alice said, man, that's difficult to get to, right? Sometimes if you're an athlete, you're not eating when you're hungry. You're eating because you need to take in carbohydrate for fuel. So you have to change the whole psychology of like eating. And not, I don't want to like even say that. Maybe, like the psychology of eating is something that's very personal to some people. But you're trying to eat so that you have fuel for the next bout of exercise. Like a race car driver is not like I try to get fuel in my car and I try to drive slowly so I can conserve fuel. So my understanding of fuel is different than a race car driver. A race car driver wants to burn the fuel very quickly. So we use fuel differently. An athlete wants to burn the fuel quickly, so they have to have fuel to burn. By the time you feel, you have to usually eat more than you actually feel hungry to eat. And clear. So as you exercise, this is a half a day, 12 hours, a full day, a day and a half, 2 days, 3 days. If you have a low carbohydrate diet, which means less than 40%, and we've always put our limit at 50%. But if I have a low carb diet, then eventually what happens to my muscle glycogen is you can see the trend, right? I'll exercise, my muscle glycogen drops. After a couple of days, it starts to increase, but then it drops because I exercise again. And then it increases, but it just doesn't increase to the level to replenish where I was before. If I have a high carbohydrate diet, which in this experiment was a 70% carbohydrate diet, then you can see it's far less of a reduction in overall muscle glycogen, given the same bout of exercise. So for somebody who's doing 2 hours of training, a 70% carbohydrate diet seems to be better than a 40% carbohydrate diet. So I don't think that everybody is doing two, or maybe they are. So maybe, for instance, Alice, I don't know how much carbohydrate you're at, but maybe the high end is 70% carbohydrate in your diet as opposed to 50, 30, 20. You know, I don't know if that's something that you're spoken to about or anything like that.
I don't think we've been told that, but I don't even think I do that, to be honest. I feel like it's more at the 40.
I mean, but imagine if like you tried to fly a helicopter with gasoline from a car, and you're trying to do something that is astounding, right? You're not being a human. You're being a jet airplane human. So like, maybe you think about that, like Flips, maybe you think of like, I don't know, maybe it's too late. I don't know, maybe it's too late, you know, but what would happen to your airplane if you fueled it with appropriate fuel? You know what I mean? Like, I'm sure it would get better. Right? So you just take a look at it. I'm not trying to tell you what to do, but if somebody said, I want to do low carb diet, what do you think of that? I would say, well, it's going to reduce your muscle glycogen over time. Doesn't make sense to me. Your brain uses only carbohydrate for fuel, specifically glucose. I don't know why you would do that. That doesn't make any sense. You know what I mean? So the number one thing that I would suggest if you're talking about carbohydrate is to understand this glycemic index thing. It makes it so that like this index, which is like a measurement of some sort, and glycemic is, emic is blood and glyce is sugar. So sugar in the blood measurement. And it's a categorization of food based on how high or how hard the insulin response is, or how hard your pancreas has to work to shuttle all the sugar to where it's supposed to be. High glycemic index foods get into your belly like a sports drink, and there's nothing to break down. It's already broken down for you. Cornflakes are already massively, refined. Pretzels, all of this stuff is just refined flour. Jelly beans just absorbs directly into your bloodstream. So if I eat 1,000 calories of high glycemic index foods, the 1,000 calories get into my bloodstream. This is like time, and this is sugar. It gets into my bloodstream. Whoop! Soon as I swallow it, it spikes into my bloodstream. That means my pancreas has to deal with these 1,000 calories over the course of minutes. And then the body doesn't know what to do with the rest of the sugar. So it takes a lot of it and processes in the liver as adipose fat. If it needs to. I don't know. not saying these, hyperbolically. This is all hyperbolically. Now, a moderately glycemic index food or a moderate glycemic index food would only be like a sugar that's more complex. And these would be sugars that are even more complex. So some types of rice have different types of starches than others. Remember, milk has lactose, and lactose is a sugar that breaks down over time. So that's a sugar. There's other ways of getting carbohydrate than straight, bread, Ezekiel bread and things like that. Fruits, some fruits have more or less or different types of sugars. One of the cool things is you could say, for instance, have a bowl of oatmeal and you can layer the carbohydrates. You could take some things that are low glycemic index food, like you could take oatmeal and put a bunch of oatmeal in here. And then you have a low glycemic index food. And then you also take some apples and some pears and you put some apple slices in there. But then you also take a little bit of bananas and you put a moderate glycemic index food in there. And you stack your pre-competition meal or pre-workout meal with carbohydrates from all different glycemic index levels. What'll happen then is the sugars burn in your intestines at different rates. So the first thing that would burn off is the maple syrup that you poured in, and the table sugar, and maybe the honey. And then that would give you energy for the first 15, 20 minutes of your exercise. But then while that's being used as fuel, your apple slices and your bananas are starting to break down. And while that's breaking down, the milk and the apples and the pears and the whole grain oats are starting to break down. And you have this like mixture that is a layered like calorie mixture that drives when the energy is going to be available as you're exercising. And you want to do all of this stuff 3 to 5 hours before competition, because otherwise it just doesn't have enough time to get out of your intestines and be ready for fuel. All right, let's move on. So let's just take a look at what that means. So I believe DJ that he's got to be 1,080, I believe, 1,080 to 4,000 calories. Is that where we were at, Skilo?
Yeah,
Something like that.
I think so.
All right, and now this is calories. And in order to get from calories back to grams, what do I do? How do I get to that conversion, DJ? Do you remember that?
Yeah, don't you divide it by 4?
Indeed. So 1080 divided by 4 is 270. That's grams, and that's the low end if you're just trying to maintain. And 4,000 divided by 4 is 1,000. So I would bet maybe, DJ, that you're supposed to be at 800 calories a day. Is that fair to say?
Yeah.
I mean, this 4,000 is probably high in 6,500 calorie diet, I would bet. You're trying to get to 5,000 calories, so you don't want necessarily 4,000 calories to be of carbohydrate. We're shooting to 50%, right? Right, 50% of your 5,000 calorie diet should be carbohydrates. So 50% is 2,500, right?
Yes.
and then divide 2,500 by 4. We're shooting actually not for 400. Let's erase it and make it the real number. We're shooting for 625 grams of carbohydrate in your diet. That's what we're looking for. So now we have to figure out, what does that mean in terms of, now let me calories divided that, yes. So we're looking for 625 grams. Or we're looking for, is that right? 270 grams. Yeah, that's what we're looking for. 10,080 calories. That's right. Divide by 4, 270 grams. Yeah. All right. So what you're looking at is, and then I always like these boil and bag rice because they're super easy. And I just used to eat them all the time. And let me just make this a little bit bigger. So, oops. Mouse. It's a bit bigger. So it says each serving size is a half a cup. And each serving, each bag is 3 servings. Right? So I have to multiply everything by 3. So there's 300 calories. 300 calories. And it says that there's 33 grams of total carbohydrate. And that's, I have to multiply that by 3. So this 33 by 3 is 99 grams of carbohydrate, total carbohydrate, 99 grams in 1 bag of rice. So if I get this smaller, whoopsies, there's 33 grams in 1 serving, and there's 3 servings in 1 bag of rice. So there's 100 grams, and multiply the 100 by 4 about, which is actually 4.4 or so. You get 450 calories in 1 boiling bag of rice. And I need you to be at 4,000 calories, but we said that not 4,000, it's 2,500 calories because you got to be at 5,000 divided by 2. So divided by 450 equals, that's about 6 bags of rice a day. 6 of those boil and bag rices a day. Now, that's not what I necessarily want you to eat, but I'm just trying to put it in perspective, how much pasta or carbohydrate you should be fueling your body with if you're trying to get to your 5,000 calories and be balanced. Man, I'm going to run out of time, but I could just keep going on and on and on. All right, maybe I'll just ask you guys. Let's do this. I know how this is going to go. Would you rather me finish what I'm doing, or would you rather me do the review for the exam? All right. Thumbs up for review for exam. Okay. All right. So I'm going to keep going for a couple of minutes and then I'll rip through the exam. Let me just keep going because it's just good information. There's some rice that has different qualities than others. So there's some rice that has this kind of starch and other rices that have this kind of starch. White rice breaks down faster than brown rice. So if I'm trying to replenish after practice and give you energy for longer, I would have you brown rice. But if I'm trying to give you energy before practice, I would give you white rice, and not sushi white rice, but like Uncle Ben's white rice, regular white rice, because it has amylopectin. Now, amylopectin is this molecule. I'm just drawing it. I'm just having fun, all right? Might not look exactly like this, but it's a branched molecule. So if the molecule wants to get digested, all it has to happen is each of these branches here, they just get ripped off and the molecule gets broken down. Amylose, though, is like a double helix. So it's like DNA. It's like wound on itself. In order for it to get broken down, it has to get unwound. And then the strands have to get broken apart. And then the pieces can get used for fuel. So this kind of starch breaks down much slower than this kind of starch. So if I'm trying to get energy before practice, I'm eating white rice. If I'm trying to get energy after practice, I'm eating brown rice. If I'm trying to run a marathon and have rice for a long period of time, I'm eating amylose. So I just have to have a knowledge of starches and a knowledge of carbohydrates, and then I can feel myself better. I can feel myself differently. All right, let's get rid of this. All right, we talked about all the stuff that's pretty important, I think. All right, the last thing I would say is this. Let's just put it in perspective here. So for DJ, he needs to be at about 5,000 calories. 5,000 calories. And 20% of that needs to be from protein. So what does that mean? Let's put that in perspective. So times 0.20. I believe that comes out to 100 calories. 1,000? 5,000 times 0.2 equals 1,000 calories. 1,000 calories. And to go from calories to the grams is divide that by 4. So that's 250 grams. Should be at about 250 grams of protein a day. And here it says, for athletes, it might be higher than normal individuals. So let's just see if our estimate here of 250 grams is right. So it should be at the very lowest 1.2 grams per kilogram, and Skilo is 90 kilograms. So that's 108 grams at the very lowest. And he's at 1.7 times 90 equals 153. So our estimate that DJ needed 250 grams of carbohydrate a day is high. Our book suggests that the highest amount that you would need for an athlete is 1.7 grams of protein per kilogram, and that puts DJ at about 153 grams. So what does that mean? What it means is this. He's got to get to 153 grams. In one large egg, there's 6 grams. In one lean chicken breast, there's 30 grams. So 3 times 5 is 150. 3 times 5 is 150. Right? 3 times 5, it should say 5. Erase. 3 times 5. And it's not 3 times 5, it's 30 times 5 is equal to 150. So I'm not saying that like he's going to want to eat 5 chicken breasts, but if he ate 5 chicken breasts at the very most, he would have enough in terms of his protein a day. And now let's take 108, because that's the low end. 108 divided by 30 equals 3.5 chicken breasts. So 3.5 chicken breasts and 7 bags of rice. We really don't need that much protein. I believe that there's 90 grams of protein in a can of tuna. So it's like 2 or 3 grams cans of tuna. You know, no more than 3.5 of these chicken cutlets. And that's what you need to get for your carbohydrate and protein. And it's 10:19. So I think I'm going to move on if it's okay with everybody.